Hello, good evening, everyone. Good evening, Mr. Samuel. Are you there? Can't hear anything. Just seeing Samuel is presenting. That's all. Hello, can anyone hear me?
Yes, yes.
Okay.
Can you hear me? Guys, can you hear me?
Yes, we can.
Okay. I think my system is having some issues. I am having audio issues, and my voice is even echoing because I'm using my mobile, my other device. Okay. Can you hear me now? All right. So sorry. My device is having issues, and if I want to start fixing it now, I think I will take longer time. So I let me just improvise before I fix it. Okay. Hope you're good. Okay, so please unmute your mics if you can hear me and just say hi.
Hi.
I didn't say shout, I said say hi.
Hi.
Okay. Um Oluwatosin,
Yeah, good evening, sir.
good evening. Afolabi, okay. Um praise are shouted
Good evening,
already.
sir.
Alright, Afolabi, good evening. Christabel.
Hello.
Good evening.
Hello.
Alright, Delight, thank you. Bila, I can see you. Okay, good evening.
Hi.
Esther, welcome, good evening. Okay, so if today is your first time joining this class, let me see your hand. Today is your first time joining us. Let me see your hand. Okay, Esther, I can see your hand. Oh, Esther is the only first time I hear.
It's our first time worshiping with us.
I swear, you're welcome. I think praise will give you first timer package.
Praise. Oh, yeah, I'm waiting. Please.
All right, okay. You're welcome. You're welcome. Um, is that the first timer package you are giving to her?
Yes, now.
You want to do heart transplant?
Nobody can give her that kind of love. Oh.
All right, okay. Um, so the other time we talked about introduction to blockchain. We talked about what the blockchain is, and as a recap, we talked about what the blockchain is. We talked about um, introduction to gas. We talked about we opened some accounts, GitHub. Okay, can you hear me? All right, so we opened some accounts. We opened GitHub account. We opened MetaMask. We opened okay, we added Sepolia. Okay, so we added Sepolia to our wallet. As I'm talking to you now, I've distanced myself from my system so that it
He's
doesn't
doing,
echo.
if you say Sepola, it says Sepola, 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 Sepola.
Sorry about that. That's why I actually distance myself from my laptop so that it doesn't sepolia. Okay. Um, we added sepolia to our MetaMask. So if you've done that, if you have opened a MetaMask account, let me see your hand. If you have opened a MetaMask account, let me see your hand. Okay, okay. This is very impressive. This is very, very impressive. Okay. If you have opened, I don't know how to say it to drop your hand. Okay. If you have opened a GitHub account, let me see your hand. Okay. This is also impressive. Okay, this is very impressive. If you have added Sepolia to your MetaMask, let me see your hand. If you have added Sepolia to your MetaMask, let me see your hand. Okay. So 9 persons raised up their hands for opening MetaMask, and then 5 out of 9 um have added Sepolia. Okay, so if you are having challenge adding Sepolia to your MetaMask, let me see your hand. Okay. So what was your challenge? Who is going first? What was your challenge? Let's do this real quick. What was your challenge? Christabel,
Hello.
what was your challenge?
Yes. Okay. So they are asking me to enter my wallet address, but I don't know the address they are talking about.
Okay. All right. Um, who else had challenge? Who else has challenge? If you have challenge, just open your mic and tell me your challenge. Ah, 4 persons raised up their hand that they've not been able to add Sepolia to their MetaMask, and only 1 person. Okay, real quick. If you want to add Sepolia to your MetaMask and they ask you to drop an address, that means they're asking you to drop your Sepolia address so that they can send the Sepolia testnet to that address that you will send to them. You understand? Okay. So um today you are going to, before the end of today, you should, before you sleep today, you should be able to add that Sepolia to your wallet. Okay,
I'm
now
not
let's
hearing you.
can you hear me? Can you
Yes.
hear me now?
Yes. Yes.
Yes.
Okay, so today we're going to talk about gas, and also how the blockchain works. So we're going to run an overview on gas and how the blockchain works. Okay. So it's important to, yes, we are going to deliberate on gas. Even after the class, I'll still touch gas one more time before we move on to what's next.
I'm not hearing.
Can you hear me now? I said
Yes,
that
sir.
we, I said that we are going to talk about gas today and how the blockchain works, and then it's important you understand what gas is and how it works as a developer so that you know how to minimize the usage of it. Like I said yesterday, it's very, very important. So I'm going to talk about it today again, and then some other time, one more time, I'm going to just rush it so that it will sink. Okay, so we just have 2 tasks today. Talk about gas and how it works, how the blockchain works. So I'm going to take you through the blockchain demo and how it works. Are we together?
Yes, sir.
Okay. All right. So let me go to my screen. So what is gas? All right. So what is gas? Let us deal on gas a little. So gas is simply the unit of computational measurement for incentive given to block validators. What's the meaning of this grammar? Yesterday I talked when I was introducing the blockchain, I told you that every block, every transaction is validated by block validators, people that run nodes. Nodes, you understand? Nodes validate transactions. Now, they are what I call block keepers. Okay, please, I really want to apologize for this echoing. You understand? So I'm sounding like God in Nollywood movie. Sorry about that. I'll fix it. Next class will not be like this. I promise. So as I was saying, blocks validators validate these transactions. Okay, and okay, there's something called consensus mechanisms, and so it is the consensus mechanism that determine how block validators validate blocks. Okay, so we have two popular consensus mechanisms. There are lots of consensus mechanisms out there. What is a consensus mechanism? In a layman term, a consensus mechanism is a protocol, like a set of rules in which a blockchain operates on. That's a consensus mechanism. And this set of rules determines how the block is being validated. So we have two primary, okay, the most popular consensus mechanism. We have proof of stake and we have proof of work. Okay, so the proof of work is um, a consensus mechanism where block validators solve mathematical problems on the blockchain and create a block. So the node that solves the problem creates the block. And when it creates the block, it gets an incentive for it. You understand? So that incentive is the mining. You are mining. Okay. Now the second one is the proof of stake. The proof of stake is those that stake their their token on the blockchain validates the transaction on the blockchain. Okay, so we are going to be looking at how the blockchain works, what is in a block, and why is the blockchain immutable. But first of all, let's talk about gas. So yesterday we we did a transaction. We added a Sepolia to our MetaMask. So if you have added Sepolia to your MetaMask, will be in one page. Okay, so let me present my screen in a way that um, everybody can see. So can you see my screen? Can you see my screen? If you can see my screen,
Yes, we can.
okay. All right. So back to MetaMask. Okay, so yesterday we added 0.1 Sepolia. Now we are going to be doing a transaction. Let me add another account to this one. Call it account 2. So yesterday we created these accounts. Now you will notice that we did when we are creating account one, we
Your screen we are seeing,
Excuse
we
me,
are
sir.
not
I
seeing
can't see
anything
your screen.
MetaMask. Oh.
oh, you're not seeing MetaMask.
Yes.
We are
It's
just
just
seeing
the
like the Google Meet.
Google Meet screen that we are seeing. The tab.
I doubt if you'll be able to
It's
show
just the
your
Google Meet tab.
MetaMask wallet. It doesn't most time. Okay.
Have you seen it?
Can't see it yet. But
I saw it just now, then it
Can
went
you
away.
see
Yeah,
it?
can see it now.
Okay. All right. So, like as I was saying, we had when we are creating our account one, we had to put in seed phrase, create a seed phrase. But when we are creating our account two, we didn't do anything like seed phrase. We just create account and it created a new account. If I want to create another account now, I can just come here and create a new account, account 3, and create. I have an account 3. Very simple. So why is this so?
Sorry, go over that again.
As I was saying, I said that you can create as many accounts as possible. Like just come here, new account, add new account. If I click on it, I will see account 4. If I click create now, I will have account 4. You understand? Are we together?
Was it in the second account you added the Sepola or in the first one?
I added Sapolia on the first account. I just created the second account just now in your presence. So there was no second account, there was no third account. Are we together? If we're together, please respond. Are we together?
No, really, sir.
Oh,
Please, can you recap?
okay,
Yes.
I will recap. I said that this shouldn't confuse you at all. Creating accounts here shouldn't confuse you at all. Okay, so it's like when you go to your MetaMask in your phone and create a new account. You understand? From with an already created account. So you have account one, you have account two. Please mute your mic. All right, we have account one, we have account two. Account you can have 50 accounts. You understand? Now later on, I will explain how these accounts are being created. So this shouldn't bother you right now, okay? The most important thing here is that we have Sepolia in our account. And so we are going to transfer some Sepolia from this account to our account 2. You understand? So please follow me as I do it. it's still not a rocket science. It's still the same thing. For those of us that have done crypto before, this will not be a news. But if you have not done it before, this is an opportunity to learn. Okay, so I'm going to click on send, and we can just pick this account too. Okay, you can just pick this account too and send. That's one. Secondly, if you want to go through the long process, let's say you want to send a transaction to another wallet that is not in this your account. Okay, so it's still the same thing as receiving. You want to receive crypto from somebody. Let's as okay, this is Sepolia now. You want to receive Sepolia from me. You have to copy your address. This one, you copy it, okay? And then when you want to send, you send it to the person that want to send you the Sepolia. Let me repeat again. You come to your address, your public address, you copy it, paste it to the person. The person will use it to send you Sepolia. And let's assume you are the one they copied the address to. You understand? Let's say this account too, and you want to receive. You understand? Now you are the account two, or your friend is the account two, and you are the account one. So you come to account, send, you paste the address. You understand? That's detected that it's account two. You paste the address, and then you put in the amount of Sepolia you want to send. Sorry, that is something. All right, so 0.01. Okay, 0.05. All right, so this is it. You can send like this and just come and continue. That's one. Do you understand? Or since you are sending to yourself, just come here, send, send to send to account two. Understand? And then 0.05. All right, so we are sending half of our Sepolia to account two. Okay, so let's go. All right, so now I'm going to show you something. Okay, so they are telling giving us this estimated fee. Okay, they are giving us this estimated fee and saying that this is the amount of fee we are paying for this transaction. Okay, this is the maximum fee we are paying. This is the highest fee we can pay for this transaction, and this is the fee we are paying for this transaction. Okay, you understand? Now, if you click on this guy, let me go back. You see this pen? When you click on it, when you see slow, market, and aggressive. Now, the gas fee you are paying for slow is very small. The gas is very small. The gas fee for market is moderate, and the gas fee for aggressive is very high. Now, when you are making a transaction, your transactions are always in a queue. The higher the transaction per time, the higher the gas fee. The lower the transaction per time, the lower the gas fee. I say it again. The higher the transaction per time, the higher the gas fee. The lower the transaction per time, the lower the gas fee. Are we together? So when
Come again.
I said that the higher the transactions in queue per time, the higher the gas fee. The lower the transactions in queue per time, the lower the gas fee to pay. So when you choose this slow, you're in the queue of 1,000 transactions and you're in number 500. When you choose this slow, you automatically put yourself in number 900, and the probability that your
Excuse me,
transaction,
sir.
yes.
I'm saying because of an error, we couldn't check for security alert. Only continue if you trust every address involved.
I didn't get your question.
I said when I'm trying to transfer the stuff, right? When I
Yes.
clicked confirm, I'm saying because of an error, we couldn't check for security alert. Only continue if you trust every address involved.
Okay, so let me give you a professional advice. If you get that, you're not supposed to get that notification. Okay, so if you get that notification, you go back again and start. So go back again and start and see if you get that notification. And then if look oh, let me cancel this transaction and start again. Send your transaction like this. This account one, this account one, and I'm sending it to account two. So I click on account two. What am I even doing here? Okay, so I click on send and then select the account. This is the account I am now with this account one, and I'm sending my token to account two. Since the account is still in my MetaMask, so no need to copy and paste address here. So I just select account two and then continue. So I'm sending from account one to account two. Again, I'm sending from account one to account two, and then all together.
Yes.
Okay, so I'll continue. As I was saying, I was here. So as I was saying, you can you can choose to take the cheaper gas fee. You can choose to take the highest gas fee. You can choose to go to the this thing. So the higher the gas fee, you choose this aggressive now. You see, instead of 60 seconds, you are using 15 seconds. That means you are jumping the queue because of your gas fee. You are now paying more. You understand? And then you are now bridging, like jumping a lot of transaction queue so that your transactions will go through. Okay, so we'll just continue with this guy, and that's it. Now, this is the transaction. You can you can see that we sent, although it's still pending. Okay, so we can see that we sent 0.01 sepolia, although it's showing us minus zero here. And then the gas limit is this. This is the gas limit. This is the gas used. This is the base fee. This is the priority fee. Total gas fee, um, maximum gas per gas, sorry, maximum fee per gas, and this is the total. Okay. Now, this transaction we just did, you can check it on the blockchain explorer. All right, so let's go to blockchain explorer and check it. Deploy blockchain explorer and check it. Okay, now let's take it step by step. Let's take it step by step. Now, this is the status. Okay, transaction hash. Transaction hash, like I said yesterday, is the key that links us to the data of our transaction. So yesterday we copied it and put it here and searched it and it brought us back because that is the what leads us. Understand? The function that leads us to the data. Understand? Okay, so now let's talk about this block confirmation. Now this block confirmation is how many blocks was minted, how many blocks was minted since the last um block before our transaction. Okay, altogether, let me
Please
explain.
come again.
This block confirmation is how many blocks. You know, I told you that it's called blockchain. Understand? How many blocks have been confirmed since the last transaction? How many blocks confirmed since the last transaction? Okay, so you hear people say that don't do any transaction until 20 block confirmation or 30 block confirmation. What they are trying to say is that let there be more blocks created before you put in your transaction. And that's for security reason. There is something in there's this attack called 50% attack. 50% attack is that when the attacker has 50% um, control over the blockchain, he can try to manipulate the blockchain, okay, by sending in wrong blocks. So sending in the wrong blocks, it creates its own blockchain, which I will show you shortly. And now by creating his blockchain, you will now be in his blockchain outside the main blockchain now because the blockchain is tamper proof. That means it self repairs itself. Once does not is not consistent, it separates itself from the main block so that they see it as a malicious block so that the main blockchain will be safe. So once somebody tries to manipulate the block, it it differentiates that block from other blocks. So for the hacker to hack the blockchain successfully, it has to have validation from the block. So the blockchain works like majority wins the vote. So if majority of the blocks is carrying one information, if the 50 if more can you hear me?
Sorry, I can't hear
I
you.
said that if more than 50%, if majority of the blocks is carrying the same transaction, that means the rest blocks are separated from the blockchain. You understand? Although this process is very, very difficult and can you hear me?
It's breaking.
Ouch. Can you hear me? Okay. So I'm spending too much time on this block confirmation. All right, so we are sending from this wallet to this wallet, from this address to this address. Okay, so the value we are sending is this. It's not up to one Ethereum, it's a poly Ethereum. You understand? And then this is the transaction fee and the gas fee. Okay, so how do we calculate the transaction fee? Transaction fee is calculated as gas price times gas use. Okay, let's see more so that we see the gas price and gas use. Okay, so this is the gas price and this is the gas use. Okay, so this is the gas price and this is the gas use. So let's, if I put my mouse pointer there, you see that. Okay, let me put the transaction fee. We said that transaction fee is gas price times gas use by the transaction. Understand? So we got this transaction fee by multiplying this gas price by this gas use. So if you multiply this by this, you will get this.
Where are you saying gas use?
This is the gas use. This, can you see it?
Yes, yes.
This one I highlighted here. Okay. So the transaction fee is the amount paid to process the transaction in Ether. You understand? So the amount you pay to process this transaction is is the transaction fee. Now the gas price is the cost per unit of gas spent for the transaction in Ether or Angwai. You understand? The cost per unit of gas, that's the gas price. The gas limit is the maximum amount of gas allocated for the transaction. She gets. And then the gas fee is based on refer to the network based fee for the time of the block, while mass fee and mass priority fees refer to the mass amount of user is willing to pay for their transaction and to give the block producer respectively. So this gas fee is what we give to the miners, the validators, the block validators. This gas fee is what we give to the block validators. Now, advancedly, you can actually set this gas fee and said, okay, this amount of money is the amount I can give. You understand? That is why when we are trying to send our Sepolia, there was a place where we can choose the gas fee we want to pay, the amount of gas fee. Sorry, I actually skipped somewhere where you can actually edit your gas fee and say this is the amount of gas fee I'm willing to pay. But the repercussion is that it can slow your transaction or even fail your transaction if the gas fee is too small to push your transaction. Now there is this bond transaction or savings fee. Now every transaction you make on Ethereum, there is a portion of it that is burnt. Okay, there's a portion of it that is burnt. All together. So um there's a portion of it that is being burnt. So this is the portion of Ethereum that was burnt from the blockchain for doing that transaction. So let me do a recap. This one is the status successful, the block confirmation, numbers of block that have been created before the last transaction. Okay, after the last transaction, sorry, and then The value is the amount of Ethereum we sent. Transaction fee is gas use times gas price. Okay, so we said that this gas fee is the amount of money you are willing to give, you are paying to those that are validating the block, the miners or the validators, the stakers, for those that for blockchains using proof of stake, and then miners of blockchain using proof of work. Okay, all right. So that's gas. If you don't get anything I just said, remember that the more, okay, the heavier the transaction, the more the gas fee. The more transaction per time, the more the gas fee. The smaller the transaction weight, smaller the gas fee. So let's say, for example, we are sending the way we send Ethereum from one address to another. Sending and receiving is a small transaction. Like the gas fee is not that heavy. If you are doing things like staking, minting NFTs, anything that is heavy duty transactions call for heavy duty gas fee. So those are the two things that determines the gas fee. Okay, so the transaction per hour, per time, sorry, and the weight of the transaction per time. Okay, all together.
Sorry, I have a question.
Please do ask.
Okay, so about the gas fee, is it
Yes.
that it's going to be deducted from the amount being sent, or it's going to be deducted from the balance of the sender? And another thing, this transaction that we just did where we sent 0 Ethereum, how come they are calculating that for us, but we are not really paying anything? In an actual transaction that involves actual money, are we going to be losing money because of the gas? Like, are they going to be deducting money from us for the gas, or I don't know?
Okay. First of all, let's come to our account too. So your question is, this transaction we just did, would they deduct it from our within call, the money we are sending? Okay, that's the question. And then secondly, I'm trying to get you, if I'm wrong, if I'm getting your question wrong, you correct me. And then secondly, if we if this how is going to be like in real-time transaction altogether, am I getting your question correct?
Yes, that's the question.
Eh?
That's the question. That's the question.
Okay. Yes, that's how it's going to be in real-time transaction. This is a test net and it carries the characteristics of real money. You understand? That's why developers use testnet, because it carries the characteristics of real money.
Sir, good evening, sir. Hello, sir.
I can hear you.
Please, I wanted to ask if this class is recorded.
Yes, it's recorded.
Um, like yesterday's class, I don't know if there's any way we can get the video so we can go through thing from today's one.
Yesterday class was not recorded, but I did a comprehensive note. I sent a comprehensive note on the group, so you can go check it out. Also, I'm still going to send a comprehensive
Is it
note.
yesterday's class or on Wednesday?
Wednesday class, sorry, Wednesday class. So the previous transaction I did wasn't I didn't specify the amount, so I just did zero. So I just sent 0.04 sepolia to my account too, and yeah, it is 0.04 sepolia. Now, if you do this transaction on a mainnet or on a real account, that's what it's going to be. And now here is your gas fee. Here you paying your gas fee from. Obviously, you are paying your gas fee from your balance. Okay. So if I check this transaction and see how much I paid in general, in total, you see that everything I paid, everything deducted from my wallet is including the amount I'm paying and the gas fee. Okay, so look at it here. The total I sent, the amount I sent was 0.04, but the total money spent is 0.04021, like that. So this 0.00021 is what I'm spending for gas fee. Look at it here. 0.000213. You see this guy here, total gas fee. If you add it to amount I'm sending, it's going to give me the total amount I'm spending for the transaction. So they are including my gas fee, the cost of my gas fee to my transaction. So I'm paying everything as once. All together. All together.
Yes, sir.
All right.
Sorry,
So
sir.
yes.
You said if I got it right, you are taking they are heavy. I don't know what I said, heavy load or something. That their gas fee is high. Is that what you said?
So I didn't get your question.
You were saying something about the gas fee, the weight to determine the cost of the fee, and you said something about the NFT and staking. Are you trying to say that their gas fee is higher than normal funds asset transaction or so?
That's what I said. Meeting an NFT
The
and
gas fee is high.
just sending the transaction is very there are two different kind of transactions. Okay. So calling a smart contract, just calling a smart contract is depending on the kind of smart contract. You know that when you're meeting an NFT, when you are doing this daily check, you are airdrop and you're doing daily checking your airdrop, you get, you can spend $0.1 for that transaction, including gas fee. So you pay to check in because everything you do on the blockchain is a transaction. You are calling you are calling it smart contract. Okay, so everything you do is a transaction. Anytime you deploy a smart contract, you are making a transaction. Okay, anything you do on the blockchain is a transaction, and you pay gas fee instant. Yeah. So it depends on the transaction you are doing. If it's heavy, you are going to pay high. If it's not heavy, you are going to pay. Okay, it's just simple. If I'm sending $500 to somebody and I'm sending $50 to somebody, who will pay higher gas fee?
500.
Exactly. So the heavier the transaction, the heavier the gas fee.
But will you really say that for an Ethereum blockchain?
The Ethereum blockchain itself is even heavy.
Will
The
you
their gas
say
fee
that
is
for
very
an
high.
Ethereum blockchain?
Sorry?
Will you really say that to an Ethereum blockchain?
Yes. In fact, Ethereum as it stands, Ethereum blockchain pays the highest gas fee. If you are doing any transaction directly on the Ethereum blockchain, you pay higher gas fee. You get. Now,
No,
why?
no, the question I'm trying to ask is, you said the higher the volume, the higher the gas fee.
Yes.
And I'm not trying to say for Ethereum, like you said, it has high gas fee. You really say it makes sense to transact low volume because even with the low volume, the gas fee seems like as if it's the same with higher transaction.
Okay, let me remember what I said, that the two factors that determines the gas fee is the weight of the transaction and the amount of transaction per time. Ethereum process small amount of transaction per second. You will not you will not compare it to a blockchain that um, process, let's say, process 1,000 transactions per second to a blockchain that process 100 transactions per second. So the blockchain that process 100 transactions per second, having 1 million transactions per time, will slow down and will pay higher gas fee to process those transactions compared to the one processing 1,000 transactions per second. I don't know if you get me.
Yes, sir.
Yes, so compared to other blockchains, Ethereum process um, minimum transaction per second. The transaction per second is small. That's why they pay high gas fee for their transactions. Now, that is what bets layer 2 blockchains like Arbitrum, Optimism. So what they do is that they expand this blockchain. Okay, they do what they call roll-ups. Okay, so what roll-ups does is that they create another blockchain, gather the old transaction and send it to the Ethereum blockchain as a block. So if a block is
Come again.
paying, I said, what the layer 2 does is that instead of paying that heavy gas fee, they create a side chain. Now we're talking about blockchain now. They create a side chain of block. They roll up all these transactions and send it back to the Ethereum blockchain as a block, to the Ethereum blockchain. So everybody in that chain of transaction now is sharing the gas fee. Everybody is paying the gas fee. So everybody's transaction now is now a transaction. And so everybody is paying that gas fee. Whereas in a transaction you are supposed to pay $10, you will pay $0.1 because we are all paying the gas fee. So that's what um, layer 2 blockchains does, and it's called scale up. It's called scaling. So they scale this blockchain so that they are still using the modalities of the Ethereum. They are using Ethereum as gas fee if you are doing that, if you are trading directly with them. But if you are doing like on their chain, they are rolling these transactions and putting it back to the Ethereum, whereas everybody is paying the gas fee. So it solves that problem of gas fee problem. Sorry, solves that problem of gas fee, of high gas fee. Sure you get. So that's why Ethereum transactions are expensive than other transactions. Okay, let's take for example, see what happened some weeks ago. The Tone block, the open network blockchain, the Tone blockchain, it had more than 2 million, I mean 3 million transactions. Is it? Yeah, 2 I mean 3 million transactions at a time. The blockchain couldn't take transactions. The gas fee was high and transactions was delayed. You get. So it either causes delay for them not to make the transaction high. They didn't increase the transaction, they increased the transaction time. So nobody's transaction was going fast. Everybody's transaction was delayed. To maintain that transaction fee, everybody's transaction was delayed, but your transaction will go, but it will take time. There was somebody that sent me USDT in Tone blockchain. The transaction took 24 hours to go through. 24 hours. So if the Tone developers want people to still get that fast transaction despite the blockchain overload, that means they will have to increase the gas fee. So everybody, the higher gas fee you pay, the shorter the queue for you. Are we together?
Yes.
All right. So everything I've said still boils down to the higher the transaction per time, the higher the gas fee you pay, or the heavier the transaction, the heavier the gas fee you pay. Are we together?
Yes,
Yes,
sir.
sir.
All right. So your after this class, try and send Sepolia to your second account. Okay, just for practice. Probably you could send 0.01. Don't just send. Just send 0.01 Sepolia, 0.01 Sepolia to your second account, and that's that. All right. So let's
Are we
talk
are
about.
we
Yes, I
sorry,
can hear you.
I didn't start at the beginning. So is there a faucet or something that will pick up this one we're buying set here? It's a test net, right?
Today's your first class, Abby.
Yes.
Uh, Ends the questions. Okay, so go back to the notes I dropped on the group. How to get a Sepolia test net. How to get the Sepolia test net is there. How
Okay.
to step by step on how to get the Sepolia test net is there. So the link to buy, sorry, I'm not buying. The link to get it is there as well. There are other faucets for getting Sepolia, but they require you to get some Ethereum on your wallet before you can get Sepolia. But the faucet you are using don't demand that. It just demand you having your GitHub account. So you sign up with your GitHub account and that's it. So that's why we actually talk about opening GitHub account, not just for the faucet, but for future use as well.
So we should create a new MetaMask for that.
Sorry?
We should create a new MetaMask for
If you have a MetaMask on your system, you don't have to create a new MetaMask. But if you want to create a MetaMask, um, primarily for testing and development, that's advisable.
yes. That's what I'm asking.
Yeah, you should. I believe you know how to do that, yeah?
I have an extension to my laptop, but if I'm using my phone, maybe I could do a 1 hour on the system.
You won't be using your phone. You'll be using your laptop, and you'll be adding it to your
So how do
extension.
I get an additional one on the laptop?
Okay.
I don't have to do
Go
1 hour on it.
go to the notes. Go through it. If you have any challenge trying to do it, drop a question, or yeah, drop a question. I will attend to it.
Yes, sir. Thank you.
Right. So a quick one. I want I want to add every student of this class to a folder on my Telegram so that I can easily just go to that place and see your messages and just attend to you instead of your message missing with all these other messages. It will be difficult for me to spot you. So as soon as we end this class, just send me hi. Okay. So as soon as we end this class, just say hi. I am this. Okay. Just say hi. My name is this. Understand? And just say hi. My name is this, and then I can easily access and answer your questions as it drops. All right. So the blockchain. So this is a blockchain demo, and then I will be going through this. Time is fast spent. I have 15 minutes to do this, so I'll try and be very fast. All right. So here we have data, we have hash. Okay. We have data, we have hash. So what's hash?
Sorry, how did you get here?
Okay. So this is the website. Um, andersbrownpost.com. You just go to your Google and search for blockchain demo. You'll see this andersworth.com as the number one. You just enter and then it will show you this. Okay. So you see something like this. Alright, so let me take it step by step. Hash. So what's the hash? Okay, so a hash function is a function that compares data. Sorry for that. Alright, so a hash is an encrypted format of a data. A hash is an encrypted format of a data. So every data has a unique hash. Alright, so let me say TEFEM. Alright, see this hash? I can't edit it. It's unique to this. So if I change this big M to small m, it changes the hash. If I remove the m, it's a different hash together altogether. If I you see that the hash is changing as the data changes. You understand? Are we together? So we have data here, we have hash here. Okay. So the Bitcoin is having is using SH256. Okay, but the Ethereum is not using SH256, but it's still in the family of SH256. I think I can't remember the name right now, but still in the family of SH256. So there are some blockchains that use different hash function, but the popular, the most popular of them is the SH256. Okay, so This is how the blockchain works. It hash data and brings them out as a hash. So, what's a block? Hmm? Who can attempt? All right, so we'll know that one very soon. Now, this is a block. We have nonce, we have data, we have the hash, and we have the block number. Okay, we have the block number, we have the nouns, we have the data, and we have the hash all together. So, what's the nouns? Okay, so the nouns is the number used in finding a solution to a block. Now, this is the first block of this blockchain now. The first block of a blockchain is called Genesis blockchain. Genesis blockchain. Sorry, Genesis block. It says Genesis blockchain. Genesis block. Okay. So this nouns now is the number used in solving the block mathematical problem. So the this block mathematical problem could be looking for the nouns that will give us a hash that starts with 4 zeros. So if I change these nouns from 8 to 5,
Please come again.
I said that the nouns is the number used in solving the block problem. For I said yesterday. I said the last class that for a block to be created, miners have to solve computational problems. You understand? Now, this computational problem is what we want to know now. The computational problem is nouns, using nouns to solve that computational problem. Now, this block, this block, the problem here is looking for the nouns, the number that will give us 4 zeros at the beginning of a hash. So if I delete 8 now and put 5, you see that it has turned red. The hash has changed. If I put 6, the same thing. If I put 7, the same thing. Until I say get. If I put 9, it's wrong. So for me to solve this problem, I have to get this nouns out together.
Refresh, please.
How do I know what the noun number should be? Is it just by guessing?
Okay, so it is not to you to know. It is it is the miners it is computers solving it. So you are not the one to carry pen and paper and start guessing the number. So while you mine, like you've heard of mining rigs, Bitcoin mining, you understand? Somebody is mining Bitcoin. Now, what is the person actually doing? The person is using his computer, a CPU, is using that machine now to solve this particular problem. Shey you get? So you are not the one to even do it. It is your mining machine, is whatever you are using, your node, your computer, your CPU, whatever you are using to mine, that does the mathematical solution for you. Are we together?
That's
So
it.
having gotten that, let when I put You see that it changes. Anything I put on this thing now changes. You get anything, any data I put on this blockchain now changes the blockchain. You see that everything I put on the data feed changes the hash. Now, this hash is what the blockchain uses to track transaction. So a block contains the present hash and the hash of the previous block. I come again. A block contains its present hash and the hash of the previous block. So that makes it a blockchain. So if I want to change anything in the block now, I will have to change the previous hash, change the previous hash, change the previous hash till I change to the first Genesis block. To the first block, which is the Genesis block altogether. Altogether.
Yes, sir.
All right. So let's look at the blockchain. All right. So this is the chain of block. So you see that this is the Genesis block of this blockchain. This is the Genesis block of this blockchain, and it carries the previous hash and the present hash. Now you see that this blockchain does not have a previous hash, so the hash here is 0. But this one here has this hash, which is 4015 and this one has 4012, which is the previous hash of this one, which is 4012. So let's have a demo on how it works. Okay, so let's say I put a data here. All right. Now this is the I have put in this data now, Christabel. It changes the hash function here. It changes the hash here, thereby invalidating all other blockchains because this one is still carrying the previous hash of this and that and that and that. She gets. So let me meet this one. Okay. So let me add Bitcoin to this mint. I want to show you something.
Oh,
Okay, so ah, hey, so all those things I typed now are waste. Okay, so let me start again. If let's say I type, let me put space up here. Hmm. Please don't keep quiet so if I'm misspelling your name. Oh. Okay, so you see that every of these transaction carries, now we now have a blockchain. Okay, we now have a blockchain. So let's say I am praise have a beef, we quarrel. I don't want, I want to come and change something that's already on the blockchain. I'll come and change praise and put it Jama. Now you see that
The hash has
this guy is
changed.
out. You understand? This block now is out. I don't understand what's going on. She gets. I don't understand what is going on. The transaction hash of this previous guy now has changed. So this guy now is carrying, why all these guys are validating and not changing is because this guy is carrying the previous transaction of this block, which is correct. But this guy now carrying the previous transaction of this is not correct. So for me to synchronize this guy to make sure that this block is
But
part of
the previous hash is the same. Oh.
the previous hash is not okay. Don't worry, I will show you. Just come in. Let me show you what I'm saying. Okay, so this guy is A, this is a node. This guy is B, this is a node. This guy is C, this is a node. Okay, so all of them carries the same thing. Let's say this A is Mr. A, Mrs. B, Mrs. C. Understand? They all have access to the blockchain. Now, if I say A here, I mean, now you see that before everybody is having the same thing. I don't know if you get. Before everybody is having the same thing, but right now this guy is alone. These guys, they don't know what he is doing. These guys are seeing the blockchain. A is on his own. And so why is it showing red? Is because, guy, this information you just put, you have changed something on the blockchain. You get? So once you change something on your blockchain becomes a different blockchain from the general blockchain. So once you change something on your computer, you have to come and change something on my computer. You have to come and change something on everybody that is connected on that node's computer for us to be in one page. I don't know if you understand. So I've
Yes, but
changed.
that's not
Yeah,
stressful.
but the second one, the previous hash is not changing, or is not supposed to change.
Okay, that's what I was saying. I said, for me to change something effectively on the blockchain, I have to change it on my computer and change it on everybody else's computer.
And I'm asking, is that not stressful?
That is
And then
why,
what if you can't find one partner or something like that? I don't know. What
exactly,
now?
that is why you can't hack the blockchain. So for me to hack the blockchain, I have to change everybody's, I have to hack everybody's computer altogether. So for us to be in one page, this guy have to be A, this guy have to be A. So I have to change A for everybody so that all of us will be in one page. So I have to mint every block so that everybody will not have one previous hash. You get? This guy is not having a previous hash. Now why it's showing red is because it's telling me that something has been altered on the blockchain. You get? So that's why everybody will not have this same previous hash. But if, let's assume A is the data, I came and changed it to APC. Understand? It's going to be standing alone. And remember, every little change changes the hash. Every data changes the hash. That is why it's difficult to manipulate the blockchain. Okay? Let's make it more realistic. Let's, okay, this is a block that has a transaction. So everybody here has this transaction. Okay? This guy too has the same transaction. This guy too has the same transaction. Understand? That's what the blockchain is all about. If Bueller now does the transaction on Ethereum, as long as I have access to the Ethereum blockchain, I'm going to see it. Although she will appear pseudo anonymous, that means I cannot see it. I will only see a public address. Understand? I will not see it. So everybody has access to the blockchain. As long you connect to the Ethereum blockchain, you have access to the node. Your computer becomes a node. All right. Let's assume that A is Darcy that did this transaction from her to Bingley. And then I want to change this guy from 25 to 30. Okay, let me do it in a mid guy now. Let me change this guy to 20. Let me do some manipulations. And then, and then there will be a problem. Now the problem here is that this guy is alone. This blockchain is alone. It's different from others because everybody is still carrying 10. Abi? Say here now. Block 3. Everybody is still carrying 10. Block 3. Everybody is still carrying 10. So for me to manipulate the blockchain, I have to manipulate it on every node, which is very stressful and impossible. You understand? So let's say a blockchain that has 20,000 validators, holders. Now 20,000 holders or 10,000 holders. That means they have 10,000 computers. So how can you hack 10,000 computers? She gets. So this is how the blockchain works. Okay. So these are the data, the nouns, the block, and the transaction hash. The hash function. Okay. So we have the block head and the block body. So the block is like a truck. Understand? The the trunk, the head, the where the driver is where you have the nouns, you get where you have the nouns and transaction hash, and then so the nouns and the hash, which is the previous hash and the present hash, and then the back, the cargo, the back is the data that carries all the transactions. Okay. So that's how the blockchain works. So in recap, I'll say that a hash is a unique length of string that serves as an identifier to a piece of data. Then why a hash algorithm is a function that compacts or computes a data into a unique hash, like the way we saw here. Whatever we put in or put out changes the hash. Okay. So we said that mining is the process of solving a block problem through computation. Mhm. And then we say nodes are.
He said mining is what?
I said mining is the process of finding problems, solving block problems using computation. Understand? Finding solutions on the blockchain, finding solutions to a block. That's mining. In a layman term, finding solutions to a block. That's mining. And then we said that okay, a block is a body of list of transactions. So a block is a list of transactions mined together. Understand? So we have this transaction, we have this transaction, we have this Darcy's transaction, we have this Elizabeth's transaction, we have this Wickman transaction, Lady Catherine's transaction, and Charlotte's transaction. All of them now together makes up the data, which makes up the block. So there are some blocks. The size of a block is about 1 MB. Yeah, I think the size of a block is about 1 MB. Now, there are some blocks that can carry 50 transactions. There are some blocks that can carry hundreds transactions. You understand? So that was what Light Litecoin now, yeah, LTC Litecoin did to Bitcoin. So the Bitcoin was slow, and then what Litecoin did was expand the blockchain, Bitcoin blockchain, not the blockchain itself. Like they cloned the Bitcoin blockchain, the same code, but this time they expanded the block. So instead of it to carry like let's say 100 transaction per block, can carry 200 transaction per block. So it will aid speed and reduce transaction fee. Are we together? And then we say that nonce is the number using solving the finding the solution to the blockchain problem or looking for the solving the blockchain problem, the block problem. All together.
Yes.
Okay. The reason why I'm rushing things is because our time is fast spent. So far we talked about gas, we talked about how the blockchain works, we talked about the gas mechanism, the transaction, and we went through how the transaction went. Okay, so there was time I would have talked about signing transaction, public keys, private keys, how the your account was hashed, you understand, and how your accounts have been created. I think in our next class we'll just talk about that signing transaction. And then I will introduce us to the Remy's IDE where we'll be using to code. So whether you want to be a developer or not, so far we have gone in a way where you can say, I am into crypto. I can do crypto transactions. I know what is done, what's happening under the hood, under the background, and then I I can send and receive cryptocurrency. Okay, so even if you have not done, if you've not done crypto before, this is a very good start. All right, any question?
I was wondering if we could have the scheme or maybe a roadmap of what we are meant to do for the
Roadmap
class.
of
As in maybe I don't know, schedule or something like that. The scheme of this class.
this class is being recorded.
No, not the record. I'm saying like
Get the
is it the timetable
video
they call it?
on TFM
As
YouTube
in
channel.
the what they call it topics for the entire section.
Yes, I believe I've sent it to the group, but I will check again. If I have not, then I'll send it tonight. The curriculum for the class.
Yes,
I think
curriculum, sorry.
yeah, I think I shared it. I shared it with us the last class. A run through on everything we'll be doing.
Okay, I'll check this. I think
Okay, like I said, in case I've not sent it, I'll just check after this class and send it immediately. But please always check the notes. For the note I sent is a Google Doc, so I will always be updating it. So always check for updates. Like this class, I will still compile it in a note form and still send it. There are some things that I've said in this class that are not in the notes, so I will still update the note and please check it, read it. I try to explain it as easy as possible so that you can. So if there's any step that like getting a Sepolia, it testnet, you can also go back there and check and you see it step by step. All right, any question? Please answer me question. 2 minutes. 2 minutes. Please answer me question. I'm begging you. Answer me question, please.
Hello, sir.
Yes, good evening.
Good evening. So, when you were talking about gas transactions, I had a question that I sent via chat. I was asking what influences the time taken for a transaction.
What?
What influences the time taken for a gas transaction? Because yeah, I saw that um, there are different timings that are taken for those such transactions.
Okay. Your question is because I said that transaction time influences the transaction with Abby.
Yeah, sure.
You're asking what influences the time.
Yeah.
Okay. Let me explain that for you. So you have you went to an ATM stand to withdraw money, and then you see 5 persons on the queue in front on the queue, and then you stand making it the sixth person, and then that's day one. Then day two, you went and saw 2 persons on the ATM machine, and you are now the third person. It will take you a longer time to withdraw money from the ATM on day one than to withdraw on day two. Am I correct?
Yeah.
Because of the queue. Abi?
Yeah. So it's the same
So
concept, right?
yeah, the same concept. Now, why are you paying a higher gas fee because of the queue? Let's say there's a security man standing by. So you just press, let's say, $2 in the hands of the security man, and it will carry you from number 6 to number 3. You understand? If you have to wait, you will not pay extra $1. But if you are in a hurry, you have to pay the security man, and he just carry you like that. Nobody will talk. Nobody will say anything. They will just act as if they did not see you because they don't have money. So you just come and stay number 3, and you, if you press $10, you press the security man very well. You will tell the guy that is even doing this transaction to withdraw to step back so that you come and withdraw and pass. That's the concept of gas
All
fee.
right. Thank you.
Am I understood?
Yes.
All right.
Hello.
Any more question before we
Yes.
draw the curtain?
Hello.
Okay, Chris. Am I correct?
Yes.
All right. I'm listening.
You talked about Ben um or something. So I wanted to know what the meaning of Ben like, in terms of doctrine.
Sorry, I didn't get your question.
Yeah, me too. I still didn't get your question. Sorry.
Um, when we were going through the gas transaction, the transaction we did on the Ethereum, you mentioned Ben crypto or something that some of the uh crypto is Ben. Please, can you get me?
I can barely hear you.
Can you
Okay,
hear?
see, just type. Okay, while I'm rounding up, just type. I will address it. Can you do that for me?
Yes.
All right, please do. Thank you. Okay, so we'll be next week. We'll be writing some codes. We'll be diving into writing smart contracts. We are here to write smart contracts. We are not here to make noise, but to write smart contracts. So we'll be writing our smart contracts very soon. But for now, let's learn what to make us write, help us write a very good smart contract. All right, your question is bond crypto. If that's correct, I want to know what bond in blockchain is. Okay, bonding of crypto in the blockchain. It means sending, it simply means sending the crypto to an address that cannot be accessed, like sending the crypto out of circulation, out of existence. That's burning. Not necessarily mean destroying it. It's just sending it to a non-existent, to an address that makes the coin non-existent. So in that address, if you send your coin to that address, you just burnt that coin. You cannot withdraw it, nobody can have access to it, it's just dead. It becomes a dead coin. That's what it means to burn in crypto.
Who creates the account for the the account where they get the address that they sent it?
Developers like you and me.
Okay, that means we have access to the call.
That's it. You don't have access to it. You don't have access to it.
Alright.
It's just, see, it's like this. You're writing a smart contract and say, guy, if I send money to you, hide it. Don't send it out. Even if I come for it, don't. In fact, there is no function to withdraw. It's just dead. Kill this coin. The smart contract said, okay. And then you send your coin to that smart contract. And then now later come back to smart contract and said, I better find me $2. I sent you $100 that time. Please send me $20. I am the developer that developed you. Doesn't work that way. That's why the blockchain is transparent. When a coin is burnt, the coin is burnt and it cannot be accessed for life. Altogether,
Yes.
am I
Hello, sir.
understood? Am I understood?
Yes, sir.
All right. So today there's not going to be an assignment. Enjoy your weekend. But if God lay it in my heart to drop you something, I could drop during the weekend. But for now, enjoy your weekend. All right. Good night.
Thanks, ma'am.